And today we are talking about Earth Day excitement and all good things Earth Day and how to turn that into action for the rest of your year and your years to come. I'm Sarah Uranowski. For anyone who doesn't know me, I head up all things product marketing here at EnergyCAP. I'm also a mechanical engineer. I have more than a decade of experience in energy and utilities, both in front of and behind the meter. And I'm very excited to introduce you to two folks, starting with my esteemed colleague and friend, Tom. So, Tom, for anyone who doesn't know you yet, which is probably not a lot of folks, but for anyone who doesn't, can you tell us a little bit about you?
Yeah, you bet. Thank you, Sarah. So I go by Tom, even though it says Thomas on the screen. My role here at EnergyCAP is I'm the Senior Manager of Energy and Utility Solutions. And what that means is I try to leverage my experience of being in the industry for more than 20 years, helping clients all around the country, so big and small organizations, save energy, reduce their costs, and ultimately try to get to be as efficient as possible, all with the under the umbrella of using EnergyCAP as a tool because it's so helpful for organizations just trying to cut and trim their waste. And with that, let me hand off now to Melanie. She's our special guest today. And so, Melanie, if you could take a second to introduce yourself as well.
Hello, I'm Melanie Stewart. I work for a small engineering company, kind of consulting company, and we recently joined IMEG to kind of take our mission nationwide. We do a lot of different types of projects, but all centered around helping to make buildings operate safely, comfortably, and more energy efficient. Prior to that, I was a sustainability manager and an owner's rep at a major medical center. And there with some of the people I still work with now, we managed to reduce energy in 5 years, we reduced it 25%, which is a big task, especially when you're looking at buildings that are occupied 24/7. But we have some good experience in knowing how to safely reduce energy use, but really show results. So
Awesome.
happy to be here.
Yeah, awesome.
All right. We're going to start off just with a little history of Earth Day after everybody hopefully got to celebrate it last year or last week. Also, last year, all the time, you should be celebrating Earth Week. So, uh, really, some stuff really started happening in the 60s. Rachel Carson wrote Silent Spring, which I think a lot of people are familiar with. What people may not be familiar with is the Santa Barbara oil spill in January of 1969. 3 million gallons of oil were spilled, created an 800 square mile oil slick. If that kind of helps you to visualize how much oil that was, confirmed more than 10,000 dead birds, dolphins, seals, and sea lions. It outraged people. It really spurred people to action, along with, I never know how to say it right, but I think it's the Cuyahoga River fire, where the river literally started on fire. So some people really started to work to organize different events across the nation, started talking about environmental rights for people, as well as how that relates to the planet. UNESCO had a conference where they really wanted to talk about the earth and peace, which I think is an interesting connection to make. And then, actually, Wisconsin Senator Nelson proposed a teach-in, which is something they had used during the Vietnam War. And that method didn't actually go over that well, but that was the kind of starting fact to get the first ever Earth Day then in 1970. So they had nationwide events. It was very grassroots led and not hierarchical. And that specific event was really championed different things across the nation, but ultimately led to the protection of the or the creation of the Environmental Protection Agency, which then created the Clean Air Act, Clean Water Act, and Endangered Species Act. So lots of things happened there very early in the 70s.
Yeah, one of
And
the things that
then,
was interesting. Oh, go ahead, Melanie. I'm
nope,
sorry.
no, please go ahead.
I was just going to add that in 1970, I think from my reading of the history, this involved about 20 million people. So as this grassroots movement grew, but most recently, as we're to current day, this affects more than 190 countries around the world. They celebrate or they have some type of action on Earth Day, and also it affects more than 1 billion people. And so it's just a really profound impact that's happened over these decades of time, which I think is really cool.
Yep. Anything you can get a billion people involved is amazing.
Absolutely, for sure. Well, I think this is where we plan for me to kind of take the reins for a while. Melanie has helped set the table and give us perspective on the history of Earth Day. What I wanted to do is run through several slides and talk about the numbers, kind of create awareness. So for the next 15 or 20 minutes, I want to talk about the numbers and talk about waste. And a lot of the stuff that's here, I think, could be used. It's great information first and foremost. But as a former energy manager myself, I was always looking for factoids and tips and ideas, things to share with people to help them understand energy waste and to motivate people. And so hopefully what I go through in the next several minutes could be used for that or for some other purpose. So with that said, let's start with some energy awareness. So quoting some of these numbers here, where 80% of global energy still comes from fossil fuels. So that's coal and natural gas by and large. So think about that, just still 80%, even with all the solar arrays that have been created and all the wind energy we're starting to capture, still 80% is coming from fossil fuels. The world uses more than 600 exajoules of energy annually. So it's a lot of energy. I mean, just so much, it's just difficult to kind of visualize to understand. Buildings consume about 30% or more of the global energy. And so one of the things that we're going to get to in the webinar today is talk about all the ways you can tune your building and carve out waste from your buildings. And what you're really shooting for is this target of trying to get to 20 to 30% of the energy reduced because, like I say, that's pretty typical for buildings across industry. If you're in the grocery sector, what you see is that probably 60% of your energy is being utilized for refrigeration alone, which is just a big proportion of your energy. Data centers now are consuming about 4% of the global electricity, but it's growing fast, and we continue to see data center headlines all the time. Number 6 here, over to the right-hand side. So the U.S. Wastes up to 2/3 of its primary energy. And if you haven't heard that term, let me just talk you through what primary energy means. The idea is if you take coal and natural gas as a for instance, and it's being burned to create electricity, there's a lot of inefficiencies that occur at these power plants, just the actual burning of the fuel and then transmitting it across electrical lines. So 2/3 of the energy, that primary source energy, is being wasted. Probably no surprise here, but China consumes more energy than the US and the EU combined. Electrification is only 20% of the final energy consumption globally. So it's still relatively low, but on the rise. I mentioned the stat here for number 9, that the 20 to 30% of the energy in a building is really wasted energy. And number 10 here, I think, is an interesting point relative to cost, is if you're not managing your peak demand, you're really not managing your energy costs. So if you're working in the industry and you're looking for ways to save dollars, yes, you should be looking for ways to reduce loads, but you also need to make sure that you're well informed about managing your peak demand to get the maximum cost savings. So where is energy going? Couple thoughts here is air conditioning alone accounts for 10% of global energy use. And what's interesting is the next bullet point there is that space cooling demand is expected to triple over the next 20 to 25 years. And so I think a lot of this is attributable to a couple things. It's a population growth. It's a lot of the population is moving to more urban areas. That's the trend that's happening in the world. And climate change also has a role here as well. And so if we're currently spending 20% of our energy on air conditioning, that number is going to triple over the course of the next several decades. The industrial sector that's consuming, or the industrial sector itself, consumes 37% of the global energy, and so that's the largest of all the sectors. This point I find is kind of interesting here, that cement production alone contributes to 7 to 8% of the global CO2 emissions. So it's a very dirty industry, is just the manufacturing of cement. Standby powers can use up to 10% of a building's electricity use. And if you're not familiar with standby power, just giving you a context here, this is the idea that when people go home from a building and a building is still, there are still equipment, pieces of equipment that are on within the building, little things that just seem to be so trivial, like maybe there will be a TV plugged in, or there might be microwaves and devices that just have small little lights and clocks and things that are operational on them. So they're all plugged in, all drawing a little bit of electricity. Just that standby power for buildings that are in unoccupied mode can amount to a very substantial amount. Transmission and distribution losses average about 8% globally. A big one here over on the other side of the chart here, where electric motors consume about 45% of the global electricity. Just pause and think about what this is saying. Motors that are out there pushing, by and large, water. So as we're pumping water, whether it's literally drinking water and water through our water systems, or if it's chill water that might be in buildings in order to cool them. So pumping of water is a big one, as well as pumping of air. So as we ventilate our buildings, those motors are being used for ventilation purposes. So 45%, like I say, of the energy is going to these motors. One of the real big wins is lights used to be 20% of global electricity, but that's been cut in half due to LEDs. So that's just one of the really big things that's happened in the last couple of decades to trim the energy use. Heat accounts for 50% of the global final energy consumption. So the energy that we're by burning coal, by burning natural gas, 50% of that energy is going to heating our residents and our buildings. EVs are 4 times more energy efficient than internal combustion engines. And an average coal plant weighs 60 to 65% of its energy as heat. And so think of this, if you can picture a coal plant that's just very vigorously burning its raw fuels, that 60 to 65% of that energy is just radiating out as heat from that plant. And so again, that's where a lot of waste is occurring, is right at the source. And finally, the last data point here, was we had a single hyperscale data center can use as much power as 50,000 homes. So if you think about 50,000 homes, I mean, that's a whole big city, and one data center could be using the equivalent amount of power. So a lot of energy going there. And Sarah, what about the next one? If you could move us to the next slide. So try to run through those stats on energy, but let's change the topic now to water. So I've got a few more numbers here that I think are pretty significant. So 17% of public water supply withdrawals come from commercial buildings. Or stated a different way, our commercial buildings are using about 17% of the water that's consumed. So all of us are paying a water bill, and about 80% of the cost of that water bill is to process the water, because it needs to be treated, it needs to be pumped, and it needs to be pressurized. The whole system has to be pressurized, and all of that is using a lot of electricity. So 80% of the cost is due to the electricity in order to get the water to where it needs to be. And these last two numbers I learned a couple years ago that are just staggering to me. Almost 250,000 water breaks occur in the US annually. So that's just a staggering number of water main leaks that are happening all around the country. And as a result, more than 6 billion gallons of treated water are wasted daily. And it's just a phenomenal amount of water that's going to waste. Next slide, Sarah. So try to give you some numbers to put this in perspective. Let's talk a little bit more about the waste that's out there and some ways that we can start to think about where that waste is and how we might try to capture it. So the biggest energy opportunities aren't capital projects. What I would describe them as is operational discipline. And you'll see over the next several slides, and as we really culminate the webinar in the next 45 minutes, Melanie and I are going to talk a lot about what we think are the organizational discipline, or just the things that businesses have to do to really capture the waste that's within their organizations. And another statement that many have heard before, but the cheapest kilowatt hour is still the one you never use. It's also the hardest to claim. So again, it's looking at your organization and trying to change the habits, the behaviors, and the strategies that are being used in order to carve out that waste. A lot of buildings are very often, they're simultaneously heating and cooling, so it's a great source of waste to try to capture. And energy savings doesn't come from one big project typically. They come from fixing a lot of the same problem everywhere. I tried to give you a little philosophy or an approach to this, and to recognize that many times it's not, again, trying to find that really big whopper of one savings opportunity. It's rigorously going about finding the little ones and putting strategies in place in order to capture them. Another stat that's out there is that 80% of building faults go undetected without analytics. So things are happening in people's buildings with their building automation systems, and many people don't even realize that's the case. And so ultimately, no action is taken. So globally, we spend trillions of dollars on energy, and so hundreds of billions are wasted. Sarah? Another thing to consider is much of this waste is fixable. Tying it back to the number I quoted a few minutes ago, this 20 to 30% of waste in commercial buildings, that's what you're going after. But what a lot of people do is they look at only projects that have a less than 2-year payback for an energy conservation measure. And hopefully through today's discussion and some of the graphs and charts that we're going to share, we can motivate and propel people to go beyond that 2-year payback, because many times even things that have 3 and 4 and 5-year paybacks have great value. Something else I wanted to highlight here is this idea of peak demand, that in most typical years, there's anywhere between 10 and 50 hours in the year where you're likely to set your peak demand. And so during those critical hours, and this is typically on the hottest or the coldest day of the year, you could suffer very significant financial penalties with your electric bills. And so recognize, if you're going to put effort into understanding your loads, it doesn't really take, you don't have to look at it so closely during the mild times of the year, but you really have to have resources and you have to put effort into understanding your loads during the times of the year when it's hot and when it's cold. And so understand that is a really critical piece to controlling your costs. Another item here that I have is equipment drift versus failure. Most equipment does not fail. And when I talk about equipment, I'm talking specifically about HVAC equipment. Most HVAC equipment drifts. The settings change, calibration begins to suffer, and ultimately energy is wasted because the equipment is no longer functioning the way it was intended. So it doesn't fail, it drifts. Temporary overrides are one of the largest sources of persistent waste. So you might have HVAC technicians in the field who temporarily override a system, or somebody working behind a computer, a building automation system, where they temporarily put something in an override state. Those get neglected and ignored. And so it's one of those things that we want to bring to your attention if you're new to this arena, where you look for that and ultimately try to change that, because it also can give you good, strong results. So energy is 3 to 5% of revenue. Whoops. But it's 20% of the energy used as controllable operating costs. So just kind of want to highlight that you can't control all of your energy use because you have a business, you have an organization that's got a mission, but usually you have the ability to control a pretty good chunk of your operational costs by putting resources in and around that. And just touching on the last thing, most organizations don't have a data problem. What they have is a prioritization problem. And so what we would say is make sure your data gets organized, make sure it gets centralized and brought together. And Sarah's going to help us with some of that here pretty soon here. But we want to talk about the prioritization problem. Make sure that you're understanding your data so that you can set the right priorities out in the field. This graphic I'd like to share with people. I think it highlights how much just a small little incremental change can affect the bottom line. And so you'll get conflicting numbers here. What I have is the note on the left-hand side that says a 1-degree change in Fahrenheit can produce a 2 to 4% savings on your HVAC. The graphic has something that's a little bit more aggressive. So this is a little bit in dispute where nobody can definitively agree what the numbers are, other than everybody recognizes that if you change your temperatures up or down in the winter and summer, you're either going to be spending more or less based on that decision. And so I like to share this graphic with people so you can begin to see how a 2 or 3-degree change, if your organization can withstand that, can have pretty significant results on the bottom line. And Sarah. So I want to bring Melanie back in, and Sarah too, if you have some thoughts here, but we want to talk about energy managers. So over the course of these first several minutes of the webinar, we wanted to set the foundation for Earth Day in its history, as well as talk about some of the numbers I've gone through with waste. But Melanie and I want to talk a lot about energy managers and the role they play within their organization, because Melanie and I have both been energy managers for a long period of time. And so I thought it would be valuable to get a little bit of insight from our time in the field. And so let me start, Melanie, and please jump in here where you see fit. But I think it's really important what energy managers do is their primary mission that really falls into a few different buckets. And it's about controlling cost. It's trying to manage the risk and compliance of the organization while simultaneously trying to do impactful projects. And those projects don't necessarily have to mean construction projects. They might be operational projects or coaching of the people in order to change their behaviors. But at the end of the day, this gets much, much harder to do without having good data in order to make these decisions. And so acting as an energy manager, worked in a large organization trying to manage more than 40 buildings and spending a lot of time in the field talking to the people and building support and trying to collaborate with people on understanding the problems and seeking solutions. And so if your organization doesn't currently have an energy manager and you're participating in today's webinar, just wanted to get you to think about the role that they play and how impactful they can be on the bottom line. Melanie, do you have some thoughts to share as well?
100% agree. I think it kind of goes back to that phrase that if it's everybody's problem, it's nobody's problem. So it's really important to have a champion, somebody that is looking at these specific things and really trying to drive that change. That energy can, as you noted, it's such a huge part of what we do and what we spend money on. But it often doesn't really get factored in when it comes to different types of projects, that you're looking at those capital projects and they're worried about how the building is going to be used and what it's going to look like. And a lot of times people don't think about, that those operational details and really trying to design something that's efficient, but also then maintain it in an efficient fashion. So having somebody that's really looking at that and championing that and working with those other entities can be really, really helpful. And they then easily pay for themselves.
Absolutely. I mean, at the end of the day, I think a lot of people understand what's best to do, but it's about the action. I think you'd agree. At the end of the day, you have to take action. You can have all the data
Yep.
you want, you can do all the analysis, but somebody has to own it. And for the organizations that don't have somebody who's committed to doing that, it falls apart. It just never achieves its ultimate objective. Sarah, I had one other slide too about energy managers that I wanted to share as well. And so again, Melanie, let me start and please jump in here. But one of the things for those on the webinar who don't really have an understanding of what energy managers are doing and some of their responsibilities, but for energy managers, it's a daily grind because they're constantly trying to chase down energy waste. They're looking at the billing data. They're typically trying to fight fires out in the field with the mechanics and the technicians who are trying to get the buildings operating properly, and simultaneously trying to make sure everybody in the buildings is comfortable and they have all of the stuff that they need in order to do their jobs well. So it's a big part of the daily responsibility for an energy manager. And at the same time, when they finally get back to their office, they're trying to collect data and do analysis, trying to propose solutions that the organization can pursue that might involve a financial investment. And at the same time, they're disaggregating data. They're using different systems, whether it's a utility bill system or it's a building automation system, to understand how things are operating and pulling graphs and charts and trying to find those anomalies. So energy managers have a very diverse role. And at the end of the day, it's just about trying to move the organization forward. And what I found during my experience is that move is slow in the beginning, and hopefully over time you pick up momentum because people see the value of what we do. Melanie, what about any other thoughts to add to that?
No, I think that's great. There just is an incredible amount of value in having someone who's working at this all the time, and helping with that cross communication between different groups, because those that are in the design are not the ones that are turning wrenches in the field, who are not the ones who are occupying and actually using the building. And so I feel like the energy manager is often kind of the communication glue that's in between those people, to really then make it an efficient building, but also one that can still be used appropriately.
Yeah, very good. So Sarah, if you could advance this one more, please. And so,
Yeah.
Sarah, I think this is where we plan to hand off to you. So again, just as I set the stage for you, Sarah, is that what we try to do these first roughly a half hour is, again, talk about the waste that's out there, talk about Earth Day. Um, One of the things we were going to do in our title is talk about the now what. Earth Day's happening, now what? And hopefully people are motivated to make change. And so let me hand off to Sarah so she can take us through some of the tools that are available and some of the important things that you have to study in order to ramp up your efforts.
Yeah, so thanks, Tom and Melanie. And we've talked, to your point, a lot about what the value of an energy manager is. And I'm super curious. I know you guys are going to talk about this later, but it's not just energy management, right? It's the culture, it's preparing the organization, it's a lot of other things. And I think one thing that's probably important is we hear a lot about lack of data. And I don't think that it's literally lack of data. I think it's sort of the opposite, that you're often drowning in data. And it's really hard to centralize that, to make those centralized insights then actionable. And it's sort of what comes from the data. So I want to just briefly go through a couple of tools, and these are tools that are available in EnergyCAP, but there are also versions of these that you can either DIY or through programs like Energy Star, which is a great place to start with benchmarking. And I waffled a little bit on if I only had two or three. And actually, I'd love to know what you guys, Melanie and Tom, what your kind of top two or three tools would be. But these are sort of mine. And it starts with benchmarking. So we're going to talk about a lot of downstream activities and walking your buildings, visiting with your buildings, and really being out in the field and some of those things as well. But benchmarking is sort of your gateway into that to help you know where to look, where to start. And of course, you could do that with EnergyCAP, but you can also do that with Energy Star if you're not just taking the basic step to submit some of your buildings, or even if you're not ready for that. Energy Star publishes some really good information, just basic EUI comparisons of your building to other peer buildings, which are a really good place to start. So there are free tools out there as well, but benchmarking is going to give you that baseline of what are my energy hogs and what are my energy stars, and how do I equalize those, and where do I want to put my time and my effort, even insofar as where do I physically want to start looking at my buildings and meters. And benchmarking can help you make kind of those critical decisions. And
Yes.
yeah, go ahead,
Sarah,
Tom.
I was just going to jump in. Just a thought that I've shared with people is that for many organizations, 80% of the energy that's consumed is found in 20% of the building. So we, as you might imagine, call it the 80-20 rule. And so as you benchmark, that's just a mindset that I'd offer to people is stay focused in the buildings where most of the energy is being used, because that's typically where most of the waste can be found.
Yep, absolutely. And as you advance in your energy strategy, Tom, I know that one of your most favorite things and mine is M&V and cost avoidance. So you talked about the best unit of energy is the one that you never consume, but then also it's sort of a secret, right? And not only for your own team and your own success as an energy manager, but so your organization is aware of what they're truly saving. It's really critical that that gets tracked and accounted for. So as you advance in your strategy, interval data submetering is really worth considering as an exercise. And another additional benefit of that, so we're talking about some activities that sort of by nature are intended to raise concerns and problems. So, even retro commissioning field audits, things like that, the intent of those is to surface those issues because they're fixable and solvable, even in really difficult environments, Melanie, like you talked about early on in the presentation. And interval data helps to surface those much quicker and faster. So if you're an average owner of an average set of buildings and you don't have all the time in the world, like none of us do, then waiting for that month to month bill data, that's a really, really good place to start. And again, benchmarking Energy Star, starting there with literally just your bill data is excellent. But as you really want to become impactful and climb, consider interval data, because that's what's going to tell you when something is going on, definitely day to day or even hour to hour, as opposed to month, or depending on your billing cycle, even longer than that. So another really key impactful place, again, as you're advancing in your strategy. And finance, so I picked finance here, but really this is about energy managers, they have so much on their plates. They get a lot of questions, but they can't exist in a vacuum. And similarly, your facilities folks, your finance teams, it's really hard for them when they're trying to exist in a vacuum as well. And you're all working from the same data set, but differently. You're looking to slice and dice it, do different things with it. The finance teams and folks who are paying the bills are looking at it differently from folks who are managing energy, are looking at it differently from safety and comfort of facilities management. And if you can get a clear and consistent view of that. So again, this is something that EnergyCAP is going to help you with. But if you're not there yet, then it's things like starting a consistent source of truth where you're at least all working out of the same data set, or you're meeting regularly to talk about these things, or just as simple as when you're finding issues, you're sending those and raising those to other folks. But again, as you're looking to advance your strategy, look for an energy and utility management tool like EnergyCAP that has those designed and built in for all of your different teams and groups. We take a special interest in finance and want to make sure that the data that you're using is financial grade, truly auditable here at EnergyCAP. But again, there's other ways to do that as well. Um, Actually, Weather Data Depot, or making sure when you're doing your own budgets and forecasts that you're using weather degree days and you're normalizing for weather and other things. There are ways to do that if you're still managing this independently. And then as you grow, hopefully with EnergyCAP, we have other tools for that as well. And then finally, this is pretty new. This is something that I'm excited to just start talking about, and that's EnergyCAP Watts AI. Michelle is actually in the webinar today. Hey, Michelle. Super lucky also that I got to spend some of the rest of my morning with Michelle talking about Watts. She's part of our beta group. But there are AI tools out there. There's lots of AI tools. We're going to be putting out some additional information, but my advice is to be really cognizant and a little conservative, very conservative actually, with the tools that you're sharing your utility data with, your billing data with. Don't just go and upload those into a generic LLM, things like that. Make sure that you as an organization are deciding how and when you want to bring AI into the mix. And EnergyCAP, of course, we are doing that, but in a very scaled and measured way, in ways that are secure for your own data. Honestly, Tom and Melanie, this is a totally different subject that I could talk about for an hour, AI and energy management, and something I think we are going to talk more and more about. But just as you go, really give thought to the energy management AI tools that are useful and helpful and safe and secure to use, and be mindful of using some of the generic tools that are out there and sharing your data and how that's distributed and what's done with it.
Absolutely. And Sarah, I just added that I just maybe the exclamation point is the output from the AI is going to be directly related to the quality of the data that goes in. So it's like you say, it's using your responsibility, but also having that great source of data to build on.
So, Melanie, I'm excited to hand back to you to talk about some of the field things and the now what that we've been talking about.
Sounds great. So now what? You're excited about Earth Day. You have data that you're tracking, and maybe you have an energy manager. And now where can you go from here? What actionable steps can you take? Whether you're the energy manager, you're a sustainability person, or someone who's just concerned about the amount of energy that your building is using. So, I getting out of your office and out into the buildings is kind of that first step. Get out there and look at stuff. Look at equipment. Look at what's happening in that building. It doesn't matter what you think is happening in that building. It's probably not what is actually happening in that building. Sometimes it's mechanical equipment, and sometimes it's equipment that is in the building, depending on what type of building that you have and what equipment is being used. People use things differently than expected all the time. And so even if you think it's normal office equipment, but you find, there's a group that's in there running a, copy machine all the time or something like that, there's always those interesting stories. So get out there and see what's happening in the building and talk to those people that you run into. Your building technicians and mechanics and things like that often have a good idea, but more about how that actual equipment is functioning. But The people that are living in that building every day can really tell you what they're experiencing, that it's hot in the morning and it's cold in the afternoon, or vice versa, or what they're noticing in terms of humidity, things that can really help guide that mechanical maintenance team into making changes that will help fix whatever is going on. And even if there's not a specific problem, that then can guide things just to make you more efficient. So, having that conversation with people really also helps engage them and have them help you more. And if you can work that in with your own team, whoever that is, but definitely boots on the ground type people, getting them engaged and excited about making changes and seeing those results. Which is my favorite thing about EnergyCAP. And Sarah was talking about cost avoidance. And I am a data nerd at heart, so I love pulling reports and looking at, that line trending down and looking at those dollars being saved. And so if you can get other people on board with that too, that momentum really builds in all ways with those people, but also monetarily and energy wise. So. I know EnergyCAP had a webinar not that long ago about auditing buildings, and that's a great step to take to really get in there and look at what is actually happening in the building, looking at different things that you can do in that space, looking at interval data like Sarah talked about to see that more nuance of what's taking place when. So you can find things that are out of the ordinary, because those are the first kind of steps to things to go get. So. And then just really work to solve problems. You don't have to have a super formal project or things like that. If there's problems that can be found that maintenance guys can just go tackle, your building automation technicians can just go do. Maybe you find out filters aren't being changed as often as they should, or maybe there's just this little leak that is taking place that nobody really seems to care about because they just think it's a little drip. But those types of things add up over time. In my experience, I've found that the longer someone has been working in a building and the older that they are, and I'm not being ageist, I promise, but there's a lot of thoughts about how to manage energy and leaks. I've talked to somebody before that, they actually calculated, oh, if it slowly drips and it's, 2 gallons a day, that costs this. And over time, but a fix is going to cost us 10 grand. And so it's not worth it. But it is worth it. And energy, water, everything costs more now. There's more fees, there's more taxes. And so it definitely pays dividends to just get out there and solve those problems. And then you also don't have to deal with the downstream problems of if that drain gets backed up and then overflows or things like that. And then lastly, but certainly not least, look at, retro commissioning your building. Retro commissioning can be a great step to look at how your building is actually operating in time, and make changes so it gets back to that operational design. And I think is that the next slide? I don't remember
It
now
Yes.
which
is.
way we're
Yes.
headed. And so that is the point of retro commissioning, is not to install new equipment. It's not to, make these big capital changes. It's just to get in there and look at what's happening in the space, fixing small things, making a list of other things that might need to be fixed and getting it back to where it was. And then once you know all your equipment is operating correctly, then you can go and make improvements from there. So again, I really advocate making data-driven decisions instead of just picking a building. Try to find a building that, follows the 80/20 rule. Use your data to go see where you have a high EUI, whether that's out of your own buildings or then always benchmarked comparatively to other buildings. Look at places where you've just had energy bills rising over time, and places that have more occupant complaints. That if people are comfortable and now they're not, something has changed that probably needs to be addressed. So the other thing that really matters is depending on where you are, but if you're in a group of buildings, a campus, or a group of community buildings or things like that, building use changes. People get moved around and shuffled, and a lot of times whoever's doing that moving doesn't think about how the building was set up. in terms of cycling air through, the amount of fresh air that comes in from outside. And so if those changes aren't made when the building purpose changes, you can lead to problems too. So it's a good way to go find buildings with those items and go get them fixed. I think that number on there, your median energy savings is 16%. That's kind of nationwide, and that's a great place to start. I think most people would be super happy with a 16% energy reduction in any building, but know that you can get more. It often, depends the older your building is and the more it's been, I don't want to say neglected, but the longer it's been allowed to just ride or drift, as Tom stated, the more savings you'll probably get. And so those are the buildings that are your low-hanging fruit to go after.
Very
Melanie,
good.
yeah, you made me think about something, both with what the building use is, but then also that example of, well, it's dripping and it's dripping so slowly, and, we've done the math and it's not really worth it. When you do that, you're making decisions in a snapshot of time, because
Yep.
I doubt probably you're going the extra step of, you're assuming that the cost of water or whatever is going to stay the same forever and ever, right? And that drip is going to cost as much in 3 years or 5 years as it does today. Or similarly, like, well, it's not really worth investigating that building because we always use it for this. We never use it for that. And then it sits that way for months or years. And those problems or issues or, oh, it's not really worth it, that changes, right? Because things change, the price of things change, the scope of that leak or how the building is used. So it's rather than making a decision about the folks that are looking at it that very minute at that very time, look at a broader spectrum of how you're using your buildings and your energy, what's coming next.
Yeah. And I don't think people give enough credence to the fact that nothing, happens in a vacuum and everything
Yeah.
is connected. And so if you have a drip, you're also, if you're chemically treating that water, you're increasing the amount of chemicals that you're having to use. Those chemicals are being transported, which increases, transportation emissions, downstream problems. You're working a pump harder than it needs to be, all kinds of things, but nothing happens independently. And so any problem that can be fixed helps you in multiple ways, even though you might not see it directly. And again, stops whatever that future problem is that is going to ruin your day.
Right. And one thing that we've talked about a lot too is tribal knowledge. There's there's a lack of energy managers, coming both into the profession and then also as they leave it. But even just in general, as things change and staff change, the fact that that leak's even there and that a decision was made not to address it could be lost. And
Yep.
then, months, years, whatever later there's a bigger issue and you're reinvestigating something that you was lost, was known and lost to tribal knowledge as well.
Yeah. One
Pretty
of the
Exactly.
things,
interesting.
yeah, one of the things I used to do when I was in the field is I would ask people, if not today, when?
Yeah.
Like if we're going to choose to de-emphasize the solution of this problem, well, when is it going to become a priority? And so are we going to accept this issue, for weeks, months, years potentially? And it's hard to combat that, right? Meaning that like you don't want to see something leak for the next 10 years. I mean, at some point, yes, it might not have a great ROI, but you do have to deal with that problem at some point. So, and to that point, Sarah, if you can move us to the next slide. Um, Both Melanie and Sarah talked a little bit about cost avoidance. And I wanted to put this in here for those maybe that haven't been exposed to this, but I have a couple of visuals. If you're not familiar with cost avoidance, I wanted to talk through. So the idea here is taking a look at establishing a baseline of energy use, having some type of event. So in this picture, that event is what's shaded in red in the middle of the diagram. So you were using a certain amount of energy, you did something. Melanie was just talking about retro commissioning. That could be the red event, or maybe it's just doing something operationally different. But then post event, you want to measure to see how you did relative to how you were doing before. So cost avoidance is this idea of comparing to a baseline and determining how much energy was saved and then turning that into dollars and cents. And why this is so important is everybody is invested in making this better. And numbers are a language that most people talk, particularly the CFOs can be intimately involved with making decisions about this. And so giving yourself the numbers to combat those questions and talk about the benefit and the ROI is just critical. And Sarah, if you can go to the next slide too, I just wanted to give a second graphic on cost avoidance here. So again, the concepts are these. You have to create a fair baseline. And if I go through the graph that's over here on the right, you have to establish your baseline conditions. And for most energy use, you have consumption that occurs regardless of the weather. And then you have a weather component. So as it gets hotter and colder, it's going to change the amount of consumption that occurs. Good cost avoidance, what you have to do is take that first bar and recalibrate it or adjust it to today's conditions. And so you might notice the blue part of the bar has grown. And you might say, Tom, why would that change? Well, if you're comparing your information this year to last year, as a for instance, maybe last year you had a 28-day billing cycle, and this year your bill is a 32-day billing cycle, you would have to reasonably adjust to expect more consumption as a result of a greater billing period. But then the weather part of this bar here in the adjusted to today's conditions bar is smaller, which means it's less severe. So the theory is this, that you take baseline conditions, you adjust it to today's circumstances, and then you compare. And so the bar to the right here, this purple bar, if you have reduced consumption and reduced weather, well, you're going to have some savings in this scenario. So cost avoidance doesn't always mean you're going to have savings. You could have losses too if things go backwards. But this is a great mechanism for determining your performance. And so just wanted to make sure that we shared in today's webinar that this tool is out there. And I want to encourage people to use it in order to do good measurement verification work and to measure the savings that's actually occurring with the projects.
I would
So
also add to that dollars is a number that everybody understands. Everybody knows what money is. Not everybody knows what a megawatt is, what a pound of steam is, but everybody speaks money.
yeah,
So when you're
Really
trying
good
to
point.
rally troops or get some buy-in, when you can show what you have saved for dollars, that counts. And don't forget your energy rates are going to go up, and so that savings gets calculated in with your energy rate. Because if you have ever had an energy rate go back down, I want to know about it because that's just not the world we live in these days. And
for
so
sure.
there's that savings is it's not correct to say multiplied, but multiplied because anything you save or don't use today has that additional amount of savings in the future. So, or avoidance, I should say.
Yeah,
That's a
good
really
stuff.
good tip. That's a
Yeah,
Melanie tip. Sometimes we have Tom tips, but Melanie, that's a really good tip. Coin
awesome.
operated. Everyone is
Yeah,
coin operated.
yeah. So you had a sneak peek of this next slide. It was a poll question. Melanie's going to take us through to the end of the webinar today by talking about some case studies, but we wanted to find out if you're currently involved, those in the webinar today, are you currently involved in a recommissioning effort or not? So if you could respond to the poll, we're just curious to see. Just Melanie and I both strongly advocate for recommissioning work, and so we wanted to take your temperature to find out where you were at. And like I say, give you another minute or so to respond. But Melanie's then going to take us through some case studies showing the profound impact of recommissioning work can do in a building in order to save energy and money.
So it's about 60-40, with about 40% of folks having been involved in a recommissioning effort and about 60% having not. So interesting mix.
That's great.
Yeah.
All right, so we're gonna just kind of talk about some different things related to retro commissioning. Um, Tom used the word drift. I used the word creep. Both are the same things. Buildings just slowly get more efficient over time. Tom specifically talked about the technicians in the building often, leaving something in hand. They go to solve a problem and it's supposed to be temporary and it's temporary forever. That happens all the time, everywhere. I think it's one of the most common things that we see that, people are trying to make somebody happy, but they don't actually solve the problem. And so that just causes an increase. In this example here, you can, see there was a pretty reasonable jump in natural gas use in September, but it's just up a little bit across the board. And it's up, 22%. That's a lot. But it doesn't stand out. It doesn't look like, oh my gosh, we're using so much more natural gas. But over the course of a year, it's 22%, which is a huge amount, of a difference to use and a huge cost. But because cost always increases, they're actually up 33% from their cost. So it's not a straight linear use cost impact. And so as fees goes up or fuel surcharges and things like that, with the more you use, you're actually paying more. So this would be your negative cost avoidance, where we want to go positive. But equipment and parts, fail. As we said, items are left in hand. And then you have the opportunity to educate people as you go and find buildings with issues like this as well. I think it depends on, kind of what industry you're in. One of the most common questions I get asked is, I don't understand why people don't fix these things. Why, if parts are failing, why aren't they just being fixed all the time? And the answer is people don't often know. It's not a broken, as Tom said, it's just a change. If you have a, damper that's supposed to fully close, but it stays open at 1%, you're leaking things, by all the time. And that adds up all the time. And so there's just little things that happen when you have a huge building with lots of moving parts. When one little moving part, even if it actually breaks, it may not get noticed in the grand scheme of things. And so this is the most common thing we see with all buildings, is that they will just slowly become more inefficient. But then you'll also see things happen. This is a spike in steam use, and I like using the two different ways to look at data in EnergyCAP, because while the line chart there shows a rather impressive increase, it's, to me, isn't as visual as the bar graph, where you see really a 6-time increase there in February. This is another unit issue where we're measuring steam in million pounds. And so if you're, just looking at like, oh, we went from 300 to 336. No, it's 300 million to 336 million. And so that's a much larger increase. And again, you instantaneously have more cost for the actual consumption, but then all your other costs that are related with that. Over time, this actually doubled their cost for the year, just for a couple months. And does anybody know why it happened, or why it suddenly got, I'm going to say, fixed? Maybe that's not quite the right word. Nobody seems to know. But my suspicion is that somebody does. Somebody did something that they forgot about or didn't know what they were doing, and then figured out the problem, and then went back and I'm going to say air quote fix that. But without being able to follow through on these things and go find out, so that you have the opportunity to educate that person, or just know what's happening in your building so that it doesn't happen again. And this is where interval data would have been really handy for this building, to find out where that spike was happening, when it happened, instead of when they got the bill. But some good successes as well. So this is a new city hall building, and they called us about 2 years after they started putting people in it, because it just wasn't working right. They had all kinds of complaints from the people living in it. They are in a building that, like, all the occupants moved from a building that was built in the 50s. So they were used to old and things that weren't working right. And so they got really excited about a new building, and then it did not meet their expectations from an occupant level. So we went in and did a retro commissioning. Technically, it was almost an actual commissioning, because it was still pretty new, but fully occupied, and had been running for 2 years. So we found more than 200 things that were wrong. Some of those are little things, but some of them are really big things, with equipment that wasn't installed right or to design specs. And that makes a big difference, because if you can't operate a building as designed if you didn't install the right equipment per those design specs. And that is a kind of crazy thing to find, and also not that uncommon anymore. People get in a hurry. They're trying to get in and out of construction jobs. They're trying to be as efficient with their personnel as possible, which usually means fast. And it's not any, in my experience, anybody doing anything nefarious. It's just the stuff that happens on a construction job site. So we went in, retro commissioned this building, had an immediate drop in their energy bills, which are not in EnergyCAP, so I don't have a good looking picture to show you there. But when we last checked with them, they had gone for more than 2 months without a single maintenance call from an occupant, which is a amazing feat and also helps save them money in a time standpoint that their building personnel can be more proactive then. So. This building is an EnergyCAP. This is an outpatient surgical center that also, has a kind of a mixed use space, some offices and patient care rooms, nothing inpatient wise, but they built this building to be LEED certifiable. So it was supposed to be pretty, what I would call green, sustainable, that they checked a lot of boxes to try and make it more efficient. We got called about 3.5 years after it had been occupied. Again, found a host of issues that were then corrected, and then we optimized the sequences of that equipment to be more efficient. Specifically, you can see a pretty good drop there in the summer. They were using still a lot of steam heat in the summertime, and for those of you that aren't involved in healthcare, you have to have a certain amount of airflow in those spaces. And so you're always simultaneously heating and cooling, but there are more efficient ways to do that so that you're not spending time heating during the summer and cooling during the winter. We also integrated their lighting system and then tied their HVAC system to their room scheduling system. And I don't know about you guys, but I have never met a person who hasn't told me their conference room is not busy all the time, which is what they think because when they go to schedule it, it's not available when they want it. That's my guess, but it is very rarely are conference rooms used all the time. And so if you have, classrooms or community spaces or things like that, that you can tie in your HVAC system so that it's the appropriate temperature when the event starts and then allow it to back off, then you're using less of that energy that's sitting, being consumed while no one's in the space. So in this case, the reduction was 3.7 million kBTU. So that's across all commodities being tracked in the building, natural gas, steam, chilled water, electricity, which is a more than 11% reduction, but also almost $108,000. And that was just in the first year. So really good payback and really good cost avoidance.
Well,
And then this is I'm sorry.
Oh, sorry, Melanie. I know, Mads, I know we're coming to the end of our time, so I don't want to miss while folks are still here, and we'll go a couple minutes over for anyone who wants to stay or is able to stay. But Madigan, I don't want to miss the poll for anyone who would like to chat more with Melanie and would like to either with IMEG or with Melanie directly. Melanie, I'm going to hand back to you, but I think there are probably folks who would like to chat more with you about the work that you do. So I want to make sure that we had time to put that poll up while we're finishing up here.
Thanks. That would be great. We're happy to talk to whoever and answer questions. And if we can help you, great. And if we can't, we can find somebody who can. So medical education building, largely classrooms and study spaces, and had been, used for a while, but certainly not an old building. Same thing, optimized, found things that were deficient and fixed them. Again, tied in that room scheduling system, and got a hefty 3 million kBTUs and a cost avoidance of 63,000 just in that first year. So project easily paying for itself. Both of these projects paid for themselves before the project was actually done. So they had their money back before the project was even complete, which is a pretty good way to go, I think. And I think then this might be the last one, just with a general office building. So, kind of 9 to 5-ish space, with, a lot of cube farms and individual offices and some conference rooms and things like that. This building was older, more than 60 years old. They did do an equipment replacement on some of it, did not do any building envelope commissioning or anything like that. We did commission the new equipment that went in, but then also came back and found some things that needed to be fixed and optimized those sequences. and really found some good savings here as well. I really like the EUI trend down there, that you can see where your commodities, like your steam in the summer went down and your chilled water in the winter went down, but then that EUI graph just takes a nosedive to make them a way more efficient building. So really good numbers there. And this was before they did their LED lighting retrofit. So they were going to do a lighting retrofit after the fact. I think they had to wait for some additional funds to come in to do that. But that will reduce that electricity use even further. So really good stuff.
Yeah, very profound results. Very awesome.
Yeah, so we do have some upcoming webinars. Please join Tom, myself, for some other things. We do have a question that was of interest before we head out. So for sites that can participate in demand response providers offer real-time interval data as part of that, but are there other ways for sites to easily view interval data, or how else can they get interval data?
Yeah, I'll jump in and offer this is personally in the buildings that I managed, my building automation system was hooked up to smart metering data. So all of that data was pulled in through the building automation system. So I was able to see that just sitting at my desk, I could pull up the screens, the dashboards, and understand better the performance of the buildings. But I think most meter installers now have software and dashboards that can be used for that purpose as well. So if your goal is to really unpack your data and get to that interval data, I think it starts with the metering and maybe even one step before that is understanding what you have to see maybe you in the buildings, if you're new to your buildings and you're just getting the lay of the land, find out what you got. Understand maybe what you have can be used for that purpose, but and then you might also add to that in order to get the visibility that you see. Melanie, I don't know if you'd add anything to that.
I would agree. Smart meters and tying things into your building automation system. Sometimes, depending on your building automation system, you can pull that data through even without a smart meter, depending on how it's set up. But I still like pulling that into EnergyCAP as a platform that, like, looking at it in the building automation system doesn't tell you what you're after. That's just not the point of the building automation system. So really being able to look at that demand in that interval data is really helpful. I also think it can really help you determine when your building is being used. I think a lot of people think like, oh, we show up early and then we leave at this time, and interval data will help you see when that is actually true, and or not, and if it's consistent every day.
Yep,
Really
good
good.
stuff.
And then last question, have you heard more about geothermal growing? I have. Curious what you guys think about increase in geothermal or discussion about geothermal.
We have as well. We're
Yeah.
seeing more projects of sizable buildings installing geothermal. We're helping with a building right now that's I think a 5-story dorm, and they resurfaced a parking lot across the street and actually put the geothermal wells under the parking lot before they resurfaced it. And so they're using that in the dorm, but we're seeing it much more commonly.
Yeah, and I would echo that and say I think part of what's happening with larger organizations or where there's district systems where they're using thermal systems and they're trying to connect buildings to share the heat, where one building is trying to reject heat and another building really needs heat. So using geothermal is the heat sink for that. So I think it is definitely growing, and I think it's going to grow even substantially more in the future is what I anticipate.
Would agree.
And last thing, Michelle, I love your call out. So we're talking about your favorite ways to celebrate Earth Day. Michelle watched a documentary about my girl Rachel Carson, Pittsburgh native, proud Pittsburgher. Thank you. Rachel Carson was the bomb. She was amazing. And also planted a new tree, an old man palm tree. So Melanie and Tom, Melanie, maybe start with you. What are some of your favorite ways? I know you guys do so much more with energy, and as do probably most folks on this call than others, but what are your favorite ways to honor or celebrate Earth Day?
I'm in Nebraska, so I'm gonna have to look up specifically what an old man palm tree is because I assure you that we don't have any of those here. So I think tree planting is great. I'm also have kind of been on a kick to plant more native plants, native to the
Mm,
area that you live
yeah.
in, of course, but to help support pollinators and birds. And I've also found that, surprisingly, I guess to me, how much cooler like a native prairie is. That how much heat a native prairie can pull in, even without like what you think of as the shade for trees.
Yeah.
And so, if you're standing in a prairie as opposed to your front yard, even if they're right next door to each other, how much cooler that is. So that's been my kind of kick of late. So trying to get rid of turf grass and plant prairie stuff.
Yeah, for me, I live in an energy management family where my wife is an energy manager. So our joy for Earth Day is teasing our family members about doing more, like turning off the lights and doing little things around their houses, turning their, setting back their thermostats when they're away for a week on vacation, that type of stuff. So we have I'll say impact in the family with our professional responsibilities.
That's great.
Well, Tom and Melanie, thank you so much, as always, for being with us today and having this great discussion. If you do we have no, we don't. I think at the beginning of this presentation was Melanie's LinkedIn and how to contact her. Feel free to reach out to us, to Tom, to EnergyCAP as well, if there are things we didn't cover that you want to chat more about. And thank you all so much. Happy post Earth Day, and we'll see you again next time.
Have a great
Thanks,
day, everyone.
everybody.
Bye
Thanks,
bye.
everyone.